What's up, interactive math students? For those of you that are deciding to view this lesson, thanks, and I hope it helps. This is obviously a weird time. This is a class that's an extra math class for you. So all I'm trying to do, guys, is to provide something that will help what your teachers in Algebra 1 are giving you, maybe showing you another way of doing something. Um, what we're going to look at today, which is going to be solving and factoring quadratics. This is part of standard 2.4. A quadratic is anything with an x squared in it, really. Okay, it's a little more technical than that, but if you're seeing x squared, it's most likely going to be a quadratic equation or a quadratic function, something quadratic. Okay, so I'm going to show you how to solve these, okay? There's a method that your teachers have probably showed you or at least are going to show you. I'll walk you through an example of that. There's another way that I kind of like showing my students that I think saves you a step, but that's up to you. Your teachers might be annoyed that I show you this, but if it helps you, that's great. If it confuses you, focus on what your teachers are doing. That's kind of a general thing with things that I give you in this class. Okay, so let's jump in here. Um, Again, if you've got a quadratic, which is anything with an x squared, perhaps your teachers have already told you that you can always use the quadratic formula. If you've ever heard myself or crazy Mr. Nicoletti in the room next to me, you guys have seen him many times. Um, he's often shouting the quadratic formula at his students, but I'm not going to sing it here. But a good way to remember it is to sing the quadratic to the tune of Pop Goes the Weasel. X equals negative b, blah, blah, blah. I'm not going to sing it. But that's a good way to remember it, okay? Here's the quadratic formula. And you can always use this when you've got a quadratic set equal to 0, okay? Now, typically, your teachers are going to have you factor the quadratics if it's factorable. They're not always factorable, meaning you can't always come up with whole numbers that you put into two sets of binomials. And that was in the lesson that I gave you guys 2 weeks ago. If you didn't view that lesson, please check it out. It might save you a little bit of time. Um, but the way your teachers are probably showing you how to solve something like this is you're first going to start with the diamond problem. And you're going to put in the top of the diamond this first term, ax squared times c. So we get a times c x squared. In the bottom, you're going to put whatever b is with x, okay? And if you're confused as heck because I've just got letters all over the place, it'll hopefully make a lot more sense when I start giving you some numbers. We try to come up with two factors that end up satisfying the diamond problem. And then comes the weird rectangle part, and that's why this gets a little bit crazy. You always put ax squared in one corner. In other words, the first term of the quadratic is going to go in one corner, and c goes in the diagonal to that one, okay? If you put ax squared in the bottom, that's fine. That just means c needs to go in the top right. You need to have some setup, something like this, and then you're going to remove a greatest common factor. Again, this probably makes very little sense until we start diving into some examples. Let's do that, okay? We've got 6x squared minus x minus 15. So in the top of my diamond, I'm going to do 6x squared times negative 15 gives me negative 90x squared. My middle term here, my b term, is just negative 1x. So I'm going to put negative 1x, which is the same thing as just negative x. I'm going to put that in the bottom of our diamond. So remember, the way the diamond problems work is I'm looking for two numbers that satisfy two things. They multiply the thing in the top, the negative 90x squared, and they're both going to add up to negative 1x. They're always going to have an x if we do it this way. And the two factors we get are positive 9x and negative 10x. that's going to multiply to the top, and that's going to add up to the bottom. So we take our we take our rectangle. The first term in the quadratic is going to go on one corner, and the corner opposite that one is going to be whatever the C term was. The two factors that you found, and that's really the tough part, okay? Coming up with the 9x and coming up with negative 10x, that's the most thinking you have to do in this problem. The rest is just remembering the process of what to do here. So I've got this crazy rectangle, and the way it works is we're going to take any row, doesn't matter which, but any row, and we're going to pull out the greatest common factor, okay? Now, let's say I were to use the top row. Okay, so 6x squared and negative 10x. What do those two terms have in common? The greatest common factor of 6x squared and negative 10x is a 2x. So now that I know, let me fill in all the inside of my rectangle here. Now that I know I've got a 2x here, it sort of becomes like a multiplication table. What do you have to multiply 2x by to get to 6x squared? 3x. What do I have to multiply 2x by to get negative 10x? A negative 5. Now I'm done with that 2x, but let's take 3x. What do you multiply 3x by to get positive 9x? 3. And then you can now check, okay, is negative 5 times positive 3 negative 15? Indeed it is, so we factored it correctly. Okay, so it's in factored form, and that should be an exponent. Let's fix this real quickly. And that. Oh, that's not what I wanted to do. Apologize. Okay. And apparently, what to do. Became invisible. So apologies for that little technical glitch there. But what we did was we turned 6x squared minus 1x minus 15 into 3x minus 5 times 2x plus 3. One extra step we now have to do because we're solving is you set each set of parentheses equal to 0. 2x plus 3 equals 0. 3x minus 5 equals 0. Solving those equations is only 2 steps. I'm not going to review how to do that because you guys, I know, can solve 2-step equations. So you get negative, so but in this one I subtract 3 from both sides, divide by 2, negative 3 over 2. Add 5 to both sides, divide by 3. X equals 5 over 3. Here's a method that I learned when I started teaching that I really like. Okay, it's going to begin very similar to how we started the last one. I made a different quadratic here. 3x squared minus 19x minus 14 equals 0. Instead of keeping the x squareds and the x's and all that in our problem, I'm going to ignore that. I'm just going to do 3 times negative 14. Remember, in the last one, you did 3x squared times negative 14. I'm just going to multiply those coefficients and get negative 40. This middle term, the negative 19, is going to go in the bottom. And now I'm less concerned with x squared and x's and more concerned with distant numbers. What multiplies to the top and adds to the bottom? In this case, it's going to be negative 21 and positive 2. Okay, but I've got a little more work to do. Remember in the last example, we had to go to the rectangle. And the way we're going to do it here is we're going to set up two fractions. Keep in mind here, this was ax squared plus bx plus c. My a term was 3. Okay? So I'm going to put ax in the top of each fraction. 3x, 3x. The two factors that we just found, which were 2 and negative 21, those are going to go in the bottom of each fraction. As you're used to, right? Anytime we've got a fraction, we tend to try to reduce this, okay? So we've got the two factors that I found as denominators, 3x and 3x. Let's simplify the fractions. The one on the left doesn't simplify. Awesome. That means it's just going to be 3x plus 2. On the right here, 3 does go into 21, okay? So I can actually reduce the fraction into 1x over 7. Right, that should be a negative 7. Whoops. So you can explain to your apologize. Let's see if we can fix this quickly, guys. Okay. Cool. Let's make it a negative 7. Still grouped. Shucks. Negative 7. Gonna make this binomial x minus 7. Oh man. Takes this long just to fix a couple problems. You can imagine how long created too. Okay. That's gonna be minus. And like before, we set each equal to 0. This was going to be minus. So I'm going to get negative 2 over 3, positive 7 over 3. Let's do a couple examples, okay? Sorry about the technical issues there. Hopefully it'll make more sense. We're going to take this quadratic here and we're going to solve this same one both ways, okay? So write down 12x squared minus 11x minus 15. And you should feel free to pause this at any time as you're watching it, okay? You don't need to watch it in real time and try to catch up. You're allowed to pause me at any moment and try to work on something. Okay? That's the good thing about recorded video. Okay, so we are going to do this together. Let's use the box method, diamond and box method first. Your teachers probably call it X box because you make the X and then you go to the box. Well, the thing that's going to go in the top of my box here is going to be negative 180 x squared. The way I got that was just multiplying 12 negative 50. The middle, or the bottom box is the middle part. That's going to be negative 11. So now we're going to think to ourselves, okay, what factors, sorry, what multiplies to negative 180 and adds up to negative 11? I think it's going to be 20 and 9. Okay, so I'm going to have 20x and 9x, but one of them is going to need to be negative. Which one will need to be negative, are you thinking? The 20. Okay, well, now we've got to go to the rectangle. Okay, so we're going to make our rectangle. Make yours with me here. And whatever the first term, 12x squared, that's going to go in the upper left-hand corner where I always like to put it. C, the last term, goes in the same diagonal as that first one. Okay, the two factors we found, again, that's where the thinking happens in this problem. 9x and negative 20x, they're going to go in the other corners. So I tend to like starting with this top row. I'm looking here and I'm thinking to myself, what is the greatest common factor of 12 and 20? Okay, and it's definitely going to have an x. You're tempted to say 2x, but there's actually a bigger factor that goes into both 12 and 20. That's going to be 4x. Okay, now that I've got that 4 though, again, now it's like a multiplication. So what multiplies with 4x to get 12x squared? 3x. What multiplies with 4x to get negative 20x? Negative 5. What multiplies with 3x to get 9x? That would be positive 3, and let's check. 3 times negative 5, negative 15. It is. So we can now create, using 3x and negative 5 and 4x and positive 3, are two binomials. Okay, that equals 0. You can set each of these equal to 0 and solve for x. Okay, and again, those are two-step algebra equations. I know you're just a pro algebra by now. So when you subtract 3 divided by 4, we get negative 0.75 or negative 3/4. You can write it either way. Here, when I add 5 and then divide by 3, I'm going to get 5 divided by 3. All right. So let's check out what this looks like using the other method. Okay. Thing. Let's do that one on a new page. So using my method, we start the same way. Ignore the fact we start the same way, but instead of putting the x's and the x squared in there, we're just going to 12 times negative 15, and we're going to put negative 11 down here. We already found the factors, and we did the problem the other way. So we know we're going to have negative 20 and positive 9. The next step, though, I think this is kind of slick, and you guys aren't the biggest fans of fractions, so maybe you don't like it. But I put two fractions down. No matter what, the first term with just an x, not an x squared, just an x, goes on the top of each fraction. Okay? The two factors we just found go underneath. Okay? Rather than trying to remove the greatest common factor and fill in the dimensions of the rectangle like we did, we're just going to reduce each fraction. Both of these actually are going to simplify. I can simplify this top one to be 3x over negative 5. And I can simplify the one on the right to be 4x over 3. And I missed writing out a mouse. Okay, now that we have those factors, now that we have the fractions simplified, very similar to how we finished the problem before. I'll go back a slide and just show you. We've now got it to 4x plus 3 times 3x minus 5. Let's deal with that. In other words, because I've simplified the fractions as much as possible, then they go into binomials that way. Okay. This is definitely confusing when you're being instructed through a smart video. So if you guys have more questions about things that your teachers are doing, please send me an email. I'd love to help you out. If there's a bunch of people asking for help on how to do this, I'd love to have some Zoom sessions and help you guys out live, but you might have enough going as it is. So I will put on our website that you should know how to get to by now, but you navigate to it from the school website. I'll put a practice worksheet on there. Do as much of it as you want. This is designed to help you in Algebra 1. The practice worksheet will have a key in the worksheet, okay? So you don't need to do the problems and hope that you're doing it right. Okay, again, send me an email if you guys have any questions. Stay healthy, get outside, but keep your distance. And we're going to get through this year at some point. Hang in there, guys. See you later.